previous class, we learned about Newton's first law of motion and Newton's second law of motion, isn't it? So, do you know which law is fundamental? That is, can you derive either Newton's first law from second law or second law from first law? Okay, today we are going to check that. Okay, so before moving to that, tell me what is the new statement of Newton's second law of motion. The statement is this, you can read it here. The rate of change of momentum of a body is directly proportional to the unbalanced force acting on it, isn't it? And then we learned a mathematical derivation or equation to calculate this force, and we have already told that Newton's second law gives a quantitative measurement of force, that is, we can measure this force. So what was that equation? Obviously F is directly proportional to rate of change of momentum, and from that equation we derived what? Very good, F is equal to ma. So this is the expression, F is equal to mass of the body, acceleration produced. Okay. So now I am going to apply a small change in this equation. Okay. I am going to make this force 0. So you should tell me what will be the value of acceleration. If F is equal to 0. That is, if the LHS of the equation is 0, then obviously RHS should also be 0, isn't it? That is, either mass should be 0 or acceleration should be 0 or both can be 0. But is there any chance for the body of any object to be 0 in normal case? No. So the only possibility is that acceleration should be 0. That is, A is equal to 0. That is, we can write a statement like this: if no force, I will just write no force, you should read it as if no force act on a body, comma, acceleration A produced is 0. A produced is 0. Or putting it into simple words, if no force act on a body which is at rest, it will remain at rest. For example, this chair, okay, it is remaining at rest. If I am not pushing, if I am simply standing, this chair won't move, isn't it? If I am not applying any force, there is no acceleration to this chair and it will remain in the same state of rest, or it will continue in its state of rest. At the same time, you will write here, if I am applying a force to a ball which is coming to me, if I am applying a force, that is, if the force is not 0, then obviously that body will stop. Either if I am not applying a force to that moving ball, what will happen? Will it stop? No, it will move in the same direction. Okay, so now can you connect with the first law? Isn't this the essence of first law of motion? What was Newton's first law of motion? You stated that every object continues to be in its state of rest or of uniform motion unless an external unbalanced force acts on it. That's what we have seen here. That is, if no force acts on a body, no acceleration. No acceleration means no change in state, isn't it? Okay, that is, the body will continue in the same state of motion. So we can say one statement or write one statement, that is Newton's second law we can say that Newton's second law is the fundamental law of motion, or we can derive Newton's first law from second law. Okay, so I hope that you have understood today's class. Thank you.